Or, hey, hi all. Good evening, ladies and gentlemen.
Good evening.
So today we will discuss a very interesting chapter, which is class 9.
Sir, I have a doubt.
1 minute, yaar. 1 minute, Krishna, yaar. How much you are telling? 1 minute. Give me 1 minute. Can you give me 1 minute?
Yes, sir.
Never take anything as a burden. Enjoy it. Okay? Life is to enjoy. Don't worry about
Okay,
it.
sir.
Okay, we will study
Okay.
gravitation. Huh?
Say nothing.
Nothing. Okay. Are you ready? You are telling something. What happened, Manaswini? You are looking little bit low today. Are you good? Everything is fine.
Yes, sir. Everything is fine.
You means you are feeling good. No
Yeah,
fever, no headache.
no,
You are missing your badminton classes.
kind of, sir.
Oh, I can understand. Okay, okay. No issues then. Okay, occasionally I think you should go
But
because
sir,
uh,
if we go like for half of the month, and like I'm going to my hometown after my exams, so
okay, then you will enjoy there. Acha. Oh, okay, okay. Where is your hometown?
sir,
Mysore,
no, sir. It's near
Davangere.
Visakhapatnam. No, no, no.
Visakhapatnam. Okay,
Yeah,
okay.
I like it.
Have you heard about Davangere?
No, sir.
You are staying in Bangalore, no?
Yes, sir.
Davangere is in Karnataka. Davangere, Hubli, Dharwad,
I've heard,
Tumkur, Chikmagalur.
sir. Yeah, but I live in a very like remote place.
Oh,
And
okay, okay. Okay, no problem, no problem. Fine, shall we start?
yes, sir.
Yes, sir.
Okay, so we'll study gravitation today. I think it is getting recorded. We will upload the recording today. Gravitation means the pull of Earth. Okay. See, first of all, take it in this way. How we are means just lying down on the earth because earth is pulling ourselves, right? So
Yes.
actually earth is pulling each and everything. Earth is pulling us, earth is pulling animals, earth is pulling trees. That is why everything is lying on the surface of earth. Okay, got it
Okay.
now?
Yes, sir.
So earth is pulling each one of us, and that force with the help of which earth is pulling us is known as gravitation or gravitational force. Is this clear?
Yes, sir.
Clear? Okay. Now, let me show you one example. Let me show you one example. Say this. Say this example. Why this apple is falling down to the earth only? Why it is not moving to the sky? Why?
So what, sir?
This you could see my screen. Is it visible?
Yes, sir.
You could see this picture.
Yes, sir.
So my question is, you could see this apple from this tree is falling down to the earth, correct?
Yes, sir.
So why it is not going towards the sky? Why it is coming to the earth only?
Sir,
Why?
because like from sky, like it's
Hmm,
atmosphere and the space is not pulling it. The
hmm,
core of the earth is like pulling it. So
right. So earth is pulling it, right?
yeah,
So earth is pulling everything. Okay, so that is why each and everything is falling towards the earth, correct?
Yes, sir.
yes, sir.
Why we are sitting on top of earth? Because earth is pulling us. So actually, earth is pulling each one of us. Now assume if the earth is not pulling, and that force with which earth is pulling us is known as gravitational force. Okay,
Yeah.
this is known as gravitational force. Is this clear?
Okay, sir.
Now, suppose, imagine if the Earth is not pulling us, then what will happen?
Sir, we'll be floating everywhere and
Correct. We'll be floating, right?
yes, sir.
And it will become very difficult to survive.
Yes.
Everyone will be floating in the sky, in the air, and we will collide, right?
Yeah, yes, sir.
So that is why, see, it is the beauty of nature. The Earth is lying on top of the Earth only, right? On surface of the Earth.
Yes, sir.
Correct, no?
Yes,
Yes,
sir.
So that's a good thing. So this is known as gravitational force, means force which Earth is exerting on each one of us. Okay. We have learned about the motion of objects and force as the cause of motion. See, if anything is moving, okay, if anything is moving, it means someone has exerted force on it. Correct?
yes,
Correct,
sir.
no?
Yes, sir.
Krishna, can you come on video, please?
Yeah. Yes, sir, sure.
I know what you are doing. That is why I asked.
Nothing, sir. Like I'm having some snack. I'm very hungry. That's
I
it.
understood. That is why I asked. I have a CCTV camera in your house.
Sir, this is sir. How, sir?
Okay. Now see,
TV in
suppose,
this room, sir.
okay, at the back of Krishna, you could see one water bottle is there, right?
Yeah, yes, sir. One water
If
bottle.
automatically that water bottle will start moving, what will happen? Krishna will run away.
I'll take that. I'll take that water bottle and keep it here, sir.
Krishna will run away, right? If the
Correct.
water bottle is moving from that table to somewhere else, so one thing is damn sure someone has exerted force on it. Yes or no?
Yes, sir.
Right? Suppose I have this box here. I have this box here. And after
Mm,
some time, I saw that this box has moved to this position. So it means someone has exerted force, then only it has been moved,
yes, sir.
right? So it means if there is a motion, if something is moving, one thing is damn sure someone has exerted force on it. Yes or no?
Yes,
Yes,
sir.
sir.
Agree? You all agree?
Yes,
Yes, sir.
sir.
Similarly, when this apple is falling down from this tree towards on the surface of the earth, it means someone is exerting force on it, right?
Yes,
Yes,
sir.
sir.
And that force is known as gravitational force. So we can tell one thing, if anything is moving, then there must be some force exerted on it, right?
Yeah, yes, sir.
Yes.
Is this point clear?
Yes, sir.
Like, see, now Manaswini was moving left, right. So how she is moving? She is exerting force on the chair. Then only the chair is moving, right?
Yes, sir.
So if anything is moving, it means some force has been exerted. Clear?
Yes, sir.
Okay. Now, next one. We have learned that a force is needed to change the speed or direction of motion of an object. This is a very important point. Is this clear?
Yes, sir.
If you want to change the speed of something, got it? No?
No, sir, your voice was breaking. Can you tell again?
1 minute. Is the voice now?
Yes, sir. It's okay.
It's better?
Yes, sir.
Okay. Now I'm telling if you want to increase the speed of something, suppose here, if we have this box, okay, and if it is moving, continuously moving, if you want to increase the speed of this, you have to exert more force or no.
Yeah, yes, sir.
Yeah, yes, sir.
Suppose you are running at a speed of 10 km per hour. Okay.
Yes, sir.
Now, suppose if you have to increase your speed, let's say 12 km per hour. So you have to exert more force or less force?
Some more
More
force.
More
force.
force. So whenever you have to increase the speed of an object, you have to apply more force. Is that clear?
Yes, sir.
Yes or no?
Yes, sir.
Okay. Similarly, see, there is a table in Krishna room, right?
Yes, sir. Makes it.
If I want to change the direction of the table, so if the Krishna will tell, hey, table, change the direction, do you think it will change automatically?
No, sir.
No. Krishna has to exert some manual force. He will go there, he will hold that table, and then he will change the direction. So it means he has to exert some force on it.
Yes, sir.
Okay. Krishna, you are doing something, you're not listening.
Nothing, sir. I'm seeing your screen, sir. 10
Okay.
kilometer per hour and 12
So
kilometer.
whenever we have to change the speed, see what is written here. Whenever we have to change the speed or direction, we have to exert force. So whenever we have to
Sir, if
change
suppose
the
one,
1 minute, no question. Hold on, let me complete.
okay, sir.
Whenever we have to change the speed or direction of motion, we need to apply force. Okay? So if you have to shift something, you have to apply a force. If you have to increase the speed, you have to apply a force. If you have to change the direction, you have to apply a force. Got it?
Yes, sir.
So for all these things, force is needed. Got it? Now,
Yes,
right now you see Krishna was moving his specs, right? Up and down.
Yes, sir.
yes,
So he was exerting force on the specs with the help of his finger, correct?
yes,
Correct,
sir.
no? Now, without exerting force, can he move his specs?
No, sir.
No. So that is what force is required if you want to shift something or increase the speed or change the direction. Ah, yeah, Krishna. Now you're asking some question.
Yes, sir. Suppose, sir, the earth does not have, like, we are floating, sir.
Hmm.
Why can't we survive while floating?
See, why I'm telling the survival will be difficult because if everyone is floating, there will be no control on us. There will be chances we may collide, right? That is what I'm telling.
Like, sir, we have oxygen to breathe, we have food to,
Ah,
uh,
yeah, then it is fine. Yeah, then we can survive. Yeah, I'm just telling कि maybe there's the chances of colliding with each other. Okay, that is what I'm telling. ठीक है?
yes, sir.
Now, we always observe that an object dropped from a height falls towards the earth, right?
Yes, sir.
If you'll go to the roof of your house and from there, if you'll drop something, where it will go?
Um, what, sir?
Okay. If you will go to the roof of your, is my voice audible
Yeah,
clearly?
yeah,
Yes,
yeah,
sir.
yes,
Yes,
sir.
sir.
I'm telling if you will go to the roof of your house, okay,
Okay.
and from there you drop a ball, leave a ball, where it will go? Towards the earth or away from the earth?
No, sir. Towards the earth.
Towards the earth, right?
Yes, sir.
So that is also an example that earth is attracting each and everything towards it. Got it?
Okay.
So this is also a good example. If someone will ask you to prove how the earth is attracting each one of us, you can tell, okay, take a ball, leave it from the roof of the earth, roof of your house, where it will go. It will go towards Earth. It means Earth is
Amen.
pulling, applying force, correct?
Yes, sir.
Now, next point is we know that all the planets go around the sun. You know this?
Yes, sir.
You know this?
Hello.
Yes or no?
Yeah, yes, sir. Yes, sir.
Right? Something like this you might have seen. Let me show you this. Right?
Yes, sir.
Yes, sir.
This is sun. All the planets are moving around the sun. Mercury,
Yes.
Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, right? Okay.
Yes.
So we know that all the planets go around the sun. The moon goes around the Earth, right? But the moon goes around the Earth.
Yes, sir.
In all these cases, there must be some force acting on the objects, the planets, and on the moon. Isaac Newton could grasp that the same force is responsible for all these. This force is called the gravitational force. Is this clear?
Yes, sir.
Earth is pulling us towards it. This is an example of gravitational force, right? These planets are moving around the sun. It means the sun is attracting all of them towards itself, right?
Yes,
Correct,
sir.
no? It is pulling all the planets towards itself, then only it is moving around the sun, no?
Yes, sir.
So this is also an example of gravitational force. Got it? Moon, moon, like moon is also revolving around the earth, right? It goes around the earth, no? That's also an example of gravitational force. Got it?
Yes, sir.
So all these are example of gravitational force.
Okay.
So in this chapter, we shall learn about gravitation and the universal law of gravitation. We shall discuss the motion of objects. Okay, we'll discuss all those things. Now, what is a gravitation? We know that the moon goes around the earth. An object, when thrown upwards, reaches a certain height and then falls downwards. It is said that when Newton was sitting under a tree, an apple fell on him. The fall of the apple made Newton start thinking. He thought that if the earth can attract an apple, can it not attract the moon? Is the force the same in both the cases? He conjectured that the same type of force is responsible in both the cases. He argued that at each point of its orbit, the moon falls towards the earth. Instead of going off in a straight line, so it must be attracted by the earth, but we do not really see the moon falling towards the earth. Now try to understand this. It's telling the same thing what I have taught you so far. Like once the Newton was, Newton,
Yeah, yes, sir.
who was the Newton? Krishna's friend.
No, sir.
Newton was a
Shashwat's friend.
great, Shashwa's friend, but Newton was a great scientist.
Yes, sir. He's a great.
Okay. He was very brilliant in mathematics and physics, so he became a scientist.
Yes, sir.
Okay. So once he was sitting under a tree and he has seen that, oh, an apple is falling on him. So then he started thinking that why apple fell on him. That is what I told you in the beginning, right? So why
Yes.
apple fell on him? It was because of the gravitational force. And then similarly, the moon, Earth is applying gravitational force on the moon, and that is why moon is moving around the Earth.
Oh,
Okay. Now this is one activity. Take a piece of thread, tie a small stone at the end, hold the other end of the thread, and whirl it around. Note the motion of the stone. Release the thread. Again, note the direction of motion of the stone. So have you tried this ever?
yeah, yes, sir.
Right.
I tried many
So here
times.
you will see that the stone will keep on moving around you. Correct.
Yes, sir.
Which path is this? A straight line path or circular path?
Circular path.
Okay, this is circular path. Is the direction direction will keep on changing?
Yeah, yes, sir.
Yes, direction will keep on changing. Clear?
Yes, sir.
Okay. Before the thread is released, the stone moves in a circular path. If this boy, whose name is Krishna Swami, if he is regularly moving this thread, what will happen? This stone will be in which path?
Stone will be in
Circular path,
circular path.
right?
Yes, sir.
With a constant certain speed and changes the direction at every point. That is what I told. The direction will keep on changing, right?
Yes, sir.
Okay. The change in direction involves change in velocity or acceleration. Now remember, whenever the direction will change, that will change the velocity. Okay? Because velocity has magnitude plus direction both. See, the direction is changing, the velocity will also change. Got
Because
it?
speed is changing.
Because?
Speed changes.
No, you have not understood. Wrong answer.
No, sir. Velocity in a circular path, velocity also changes because speed is also changing, right?
No, no, wrong answer.
And what is the answer,
You
sir?
are always in a hurry. Velocity is made up of a speed plus direction.
Okay.
First of all,
The
is this
speed.
point clear?
Yes, sir.
If the speed will change, velocity will change. If the direction will change, velocity will change. Is this clear?
Yes, sir.
Manaswini, is this clear?
Yes, sir.
Okay. Now, okay, suppose Manaswini, when you are playing badminton, is your speed always constant or it keeps on changing?
Keeps on changing, sir.
Keeps on changing. Sometimes you have to quickly means throw that what's the name of that here?
Cock.
A cock, yeah. So accordingly, you have to increase the speed, decrease the speed. You have to change the direction, right? Very quickly, correct?
Yeah, yes, sir.
So now, in this case, which I am showing you, if this boy is moving this speed at a constant speed, okay. So, but do you think direction is changing or not?
No, sir. Direction is not changing.
Why? See, this is in a circular path. At this point of time, this stone is in this direction, right?
Yes.
Let me explain this. Let me explain this. 1 minute. Don't worry. See, in this diagram, at this point of time, this is the stone. So, what is the direction of this stone? This is in this direction, right?
Okay.
Correct?
Yes, sir.
After some time, this stone will reach here, no? Where is that? This stone will reach somewhere here.
Yeah, yes, sir.
Then at this point, what will be the direction?
Yeah, that
This will
time.
be the direction.
Yeah, yes, sir.
So direction has changed or not?
Yes,
Yes,
sir.
sir.
So at each and every point, the direction will keep on changing. If the direction will change, velocity will change or not?
Yes, sir.
Yes, that is what I'm telling. So before the thread is released, the stone moves in a circular path with a certain speed and the direction changes at every point. So if this boy is constantly moving this stone in the circular path, that the speed will be constant, but the direction will keep on changing. And if the direction will change, velocity will also change. Is this clear?
Yes, sir.
So velocity depends on what?
Depends upon
Change
the
in the
speed
direction
and
and
direction.
speed.
Velocity depends on speed and direction both.
Yes, sir. I said the both.
Correct. If the speed will change, velocity will change. If the direction will change, velocity will change. If the speed and direction both are changing, velocity will also change.
Change.
Clear?
Yes, sir.
Krishna Swami, is this clear? Understood?
Yeah, yes, sir. It's clear.
Okay. What you are doing now? You are calling someone?
No, sir.
Okay. The change in direction involves change in velocity or acceleration. The force that causes this acceleration keeps the body moving along the circular path is acting towards the center. This force is called the centripetal force. Now, this force, this boy is exerting some force now to keep this stone moving in the circular path. Yes or no?
Yes, sir.
Sir.
No, no, tell me, I'm asking the question again.
Yes,
This
sir.
boy is keeping this stone moving in the circular path, correct?
Yes,
Yes,
sir.
sir.
So to keep this moving in the circular path, this boy Krishna Swami is exerting force or not?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
So this force is known as centripetal force. Is this
Uh,
clear now?
yes, sir.
Are you sure this is clear?
Yes, sir. It's clear.
Okay, good. Why this is known as centripetal force? Because this force will be acted towards the center. This Y is at the center, no? So that is why it is known as centripetal force. Now, Manaswini is going to sleep.
No, sir.
No, I think you're not that much active today. You're not taken food?
No, sir. I have taken.
Okay. So fine then. This is clear?
Yeah, yes, sir. That's clear.
Okay. In the absence of this force, the stone flies off along a straight line. Now suppose here in this example, if this boy will release this thread, then what will happen? Where it will go?
Sir, the stone will go far away.
Far away, right? If we
Yeah.
will release it here, it will go in this direction somewhere,
Yeah,
right?
yes.
And if someone is standing here, it will hit it.
Them.
Correct?
Yeah, yes, sir.
So we should do this activity or we should not do this activity.
We should
Uh,
do, sir.
no,
Now,
sir.
see, Krishna will tell this only. I was expecting the same response from Krishna. You will do this so that it will hit someone, right? And he will get wounded.
No, sir.
What is
Sir,
your
I go to
intention,
an open
Krishna?
field and I'll do, sir. Where
You
nobody will
will
come.
go in open field, Sri Harikota, you will go, right?
No, sir.
And you will release it.
Why, sir? To
sir,
damage
it
one
will
rocket,
hit
sir. No,
sir,
sir.
not
If I
kill it.
damage one
Okay.
rocket, then they will give me one crore bill, sir.
Not one
Okay,
crore,
okay.
more than that.
For replacing the damage, they'll give only 1 crore. If I damage that whole rocket, they will 50 crores, 60 crores.
60 crore rupees. Yeah.
Even, sir, not even 60, sir. They'll take more than 500.
Okay, okay. Your story will start just okay. You need some excuse and your story will start. Okay. Suppose if this person will release this thread, then where this will go?
Say, along that straight line, it will go hit someone or falls
Very good. It will hit someone. So what is the path of this stone then?
straight. Like,
Very good, Manaswini. Very good. So if that person will release that thread, it will go in a straight line. Correct?
yeah, yes,
Got
sir.
it?
Sir.
The straight line will be a tangent to the circular path. You know what is tangent?
No, sir.
Y- Sir, is straight.
Tangent you don't know?
No, sir.
So you
Okay,
just said
see.
before.
Suppose this is a circle. No need to suppose this is actually a circle only, okay?
Okay, sir.
Now on any point, if I will draw a straight line just touching it. See, this is straight line is just touching it here, right?
Yes, sir.
So tangent means a straight line which will just touch the surface of circle. That is known as tangent.
Okay, got it, sir.
Krishna, is this clear?
Yes,
Krishna
sir.
Kumar 1027. Is this clear?
Sir. Yes, sir. I
Tell
got
me.
it.
Clear? Okay. If it is clear, I have a question for you. Who will answer?
Me.
Sir, I'm ready.
Okay. Is this a tangent?
No,
No,
sir.
it's a
Why?
card.
Because it's not touching the outer part of the circle.
It is touching the circle, but at how many points? 2 points.
2 points.
This point.
Okay.
Tangent means it should touch the circle only at a single point. That will be the tangent. Clear?
Yes, sir.
So in a circle, can you tell me how many tangents are possible?
Infinite. Not infinite, but yeah.
4 maximum, sir.
Maximum 4. I was expecting same incorrect answer from Krishna Swami.
Sir, 4 only right, sir.
How
Sir,
4, Krishna?
sir, by the perimeter, like if
By the
uh,
diameter.
Okay, see, this is one tangent. Okay, I will draw another tangent. कहाँ गया?
can draw many.
This is not a tangent.
It's
That
a
is a
tangent, sir.
tangent.
Yeah, okay, infinite, sir.
Not
This is
infinite.
not a tangent.
That is a tangent.
Yes, sir, that's a tangent.
This is not a tangent.
Yes, sir, it's a tangent.
This is not a tangent.
Sir, it
Yes,
is.
sir.
Sir,
Now
but
tell me how many tangents?
Many.
Infinite number of tangents you can draw on a circle. Clear?
sir,
Yes.
like how infinite, sir? Because
Hmm.
like in a perimeter itself, we can take it and draw, right? Like
First of
I'm
all, circle doesn't have perimeter. That is circumference,
It's a
right?
diameter.
okay, yeah.
Diameter. Very good, Krishna Swami. That is a
Sir,
diameter, right?
Circumference,
Very
I mean,
good. Congratulations.
circumference, sir.
so
Circumference.
sir,
Sorry.
so to for each point, like there a tangent passes means it'll be the circumference itself, right? So we cannot pass infinite.
See, right now, how many tangents are there on this circle?
One,
One,
three,
two, three, four. Count
and
it.
one.
Is this not a tangent to this circle?
Sir, it is.
Five. Is this not a tangent to this circle?
Sir, it is, sir, but
Six.
fine. Got it, sir.
So how many tangents you can draw?
Sir, infinite.
Infinite.
Infinite. Krishna, is this clear?
Yes.
Okay, good. So that is what when this person will release it, it will go along the tangent. Okay,
Okay, sir.
clear?
Yes, sir.
Okay.
The motion of the moon around the earth is due to the centripetal force, the same force earth is exerting on moon. Earth is trying to pull moon towards its center, and that is what the centripetal force, and that is why the earth keeps moving around the earth.
Okay, sir.
Earth is moving around the sun, right? True or false?
True, sir.
Very good, very good, very good.
No, Earth is moving around the sun.
No, sorry, I asked moon is moving around the earth. Is that true or false?
Moon around the earth.
Didn't understand the question, sir.
Moon is moving around the sun. Is that true or false?
That's wrong.
True.
False.
So moon is moving around what? Earth or sun?
Earth, sir.
Earth. So now I
And
am
Earth
showing
is
you.
around the sun.
Now I am showing you very dangerous image. Okay,
What is the dangerous, sir?
this is the dangerous image.
Sir, what is it, sir?
What is this?
Sun,
Sun.
sir.
What is this?
Earth,
Earth,
Earth.
sir.
Earth. See, here is India,
Yes,
right?
sir.
And here
Yeah.
is Hyderabad, here is Bangalore. Okay, and this is our moon, right? So
Yes.
this sun is moving around this direction. See, oh yeah, zigzag line here. See, Earth is moving in this direction. तो गलत हो गया. Just a minute, guys. लाइन कट तो नहीं है वजह से तो स्ट्रेट लाइन जगह ही जाएगा कर्व तो लाइन दिख नहीं रहा ठीक है छोड़
Sir,
ओके
it's up. Yeah.
अरे मैं क्या हूँ so this earth is moving in this way around the sun, right?
Yes, sir.
So this is the path of earth around the sun. It will keep on moving like this,
Sir.
correct?
Hmm.
Earth
Yes,
is
sir.
moving around the sun. Why earth is moving around the sun? Because of which force?
Centrifugal? No.
Gravitational force it is applying, right?
Yes,
Now
sir.
the sun is moving around the earth. Earth is pulling this moon around towards its center. That is why this force is centripetal force. Is that clear now?
Yes, sir. It's clear,
So
sir.
So
could you explain
Earth
one
is attracting which force on moon? Earth is exerting which force on moon?
centrifugal force? Oh,
Centripetal force,
centripetal. Okay,
right? Centripetal. Towards the center it is exerting. That is why it is a centripetal force. Got it?
Yes, sir.
Okay. The centripetal force is provided by the force of attraction of the earth. So when the moon is rotating around the earth, who is exerting force on the moon?
Sir, Earth is.
Earth, right? And that is
Yeah.
because the attraction of the earth, and this force is known as centripetal force because this force is towards the center of the earth, right?
Yes. Yeah.
Okay. If there were no such force, the moon would pursue a uniform straight line motion. If
Yeah.
suppose the earth is not pulling
But
this moon, then what will happen? This moon will go somewhere here, a straight line, it will go outside.
yes, sir.
Then you think in that case you will be able to see the moon?
No, sir.
It will be lost somewhere, right?
And then nights will be too dark. Like we can't.
Very good, Manaswini, very good. Clear?
Yes, sir.
Okay. It is seen that a falling apple is attracted towards the earth. Does the apple attract the earth? If so, we do not see the earth moving towards an apple. Why? Very good, interesting question.
So
If
can
an apple is falling towards the earth, so we are telling earth is pulling the apple, exerting force on the apple. That
Yeah,
is why
yes, sir.
apple is coming towards the earth, right?
Yeah,
yeah.
yes.
Then the question is, don't you think in that case this apple is also exerting force on the earth?
Ah,
Not understood. Question is not clear.
clear, sir.
Question is, earth is exerting force on the apple? Yes or no?
Yeah, yes, sir.
Yes. So is the vice versa true? Do you think apple is also exerting force on the earth?
No.
No, sir.
Apple is also exerting force on the earth. That
How?
is true.
How, sir?
I will show you that. Okay, we have a formula F equals G into M1 M2 by R square. Apple also exerts force on the earth, but the magnitude is too small. That force doesn't have any impact on the earth.
Okay, sir.
Got it?
Yes, sir.
Suppose if I will ask Krishna to move the wall, okay, do you think he will be able to move the wall?
No, sir.
No. Why? Because the force which Krishna will exert on the wall, it will be very less to move it, correct?
Yes, sir.
Sir.
Now, if I will call a bulldozer, it can move it easily. Why? Because it is exerting a very large force.
Yeah. Yes, sir.
Yes.
Similarly, this apple is also exerting force on the earth, but that force is very less. That is why there is no impact. You could
Yeah.
not see any impact on the earth.
Okay,
Okay.
sir.
So now I have a question. Are you ready?
Yeah. Yes, sir.
So, is earth exerting force on your Manaswini?
Yeah.
Yes, it is exerting force on you.
Yeah. Yeah.
So, do you think you are also exerting force on the earth?
Yes, sir.
Yes, you are also exerting force on the earth, but that magnitude is very small that we cannot see any significant movement in the earth, right?
Yes, sir.
Got it?
Yes, sir.
So is Krishna exerting force on the earth?
Yes, sir.
Yes. So everyone is exerting force on the earth. Is this clear?
Yeah, yes, sir.
Krishna, is this clear? Krishna is playing with something.
Drinking
No?
water.
Okay. According to the third law of motion, the apple does attract the earth, but according to the second law of motion, for a given force, acceleration is inversely proportional to the mass of an object. Okay? What is
Yes,
the
sir.
third law of motion?
Every action has an equal and opposite reaction in the direction.
Correct.
Yes, sir.
And opposite reaction.
To every action, there is an equal and opposite reaction. If you will exert a punch on the wall, you will also get some impact from the wall, right? And it will hit your fingers. Correct?
Yeah, yes, sir.
So Krishna will give a demo now.
What, sir?
Give a give a strong punch on the wall.
Where should I, sir?
So the wall will also hit you, right? You will get hurt, correct?
Yes, sir.
So that is a very good example of third law of motion, right?
Yes, sir.
Manaswini, have you studied this third law of motion? Yes or no? First of all, tell me.
Yeah, yes, sir. I have.
You studied, no?
Yes,
See,
sir.
when you are walking on the floor, so what you are doing, you are pushing earth towards backside, and then earth is pushing you the towards the front side, and that is why you're able to move, right?
Yes, sir.
Yes,
Correct,
sir.
no? That is also an example of third law of motion. Got
Yes.
it?
Yeah, yes, sir.
Okay. So same thing is happening here. If the earth is pulling apple towards its center, when towards it, so apple will also exert force on the earth. That is what I told you. Okay. But that magnitude is very small. Okay, it is not having an impact.
Oh,
Yes.
yeah.
Okay,
Yes, sir.
got it?
Yes, sir.
Now, acceleration is inversely proportional to the mass of an object. Equation 8.4. The mass of an apple is negligibly small compared to that of the earth, so we don't see the earth moving towards the apple. Extend the same argument for why the earth does not move towards the moon. Now, see, why, if the apple is exerting force on the earth, then why earth is not moving?
So because Apple's magnitude, it is giving very less force as compared to that of the Earth.
Yes, why? Because the mass of apple is very less as compared to that of earth.
Yeah, okay.
See, this is the second law of motion, no? F equals to m into a,
Yes, sir.
right? Now, can we write here a equals f by m? Can we write this? Yes or no?
Yes, sir. We can write.
Manaswini, yes or no?
Oh,
Huh?
yes, yes, sir.
Now, this is what is the relationship between acceleration and mass m? Directly proportional or inversely proportional? What is directly proportional and what is inversely proportional? Do you know this?
Directional means if the force rises, uh, like, uh, if the value of something rises, the others also rises.
Correct.
Yeah, and then inversely proportional is when one thing rises, another one declines a lot.
Correct. So here A is in numerator and M is in denominator, right?
Yeah, huh, yes, sir.
So when you have to find the relation between two quantities, and if one is in numerator and the other is in denominator, then the relation will be inversely proportional. So we can tell A is inversely proportional
To
to
M.
M.
Okay.
Inversely proportional means if M will increase,
Then
A
A
will
will
decrease.
increase. And then if A increases, M will decrease.
Correct. Or you can tell if M, yeah, if M increases, so A will decrease, and if M decreases, A will increase. Got it?
Yeah,
Yes,
yes,
sir.
sir. Yes,
Okay, clear?
huh, yes, sir.
Okay. So now in the case of Earth, if Apple is exerting force on the Earth, so what is the mass of the Earth? It is very large, very huge, correct?
Yeah, yes, sir. It's very huge.
So then the acceleration will be very less
Yeah, yes,
because
sir.
acceleration is inversely proportional to mass.
Yes,
If
sir.
mass is less, acceleration will be more. If mass is more, acceleration will be less. So in case of Apple exerting force on the Earth, Earth has a very huge mass. So then acceleration will be less or more?
Le-
Less.
Yes,
Less,
sir.
because the mass is very huge here, right?
Yes,
Sir, I'll
sir.
come in 2 minutes, sir.
Okay, sure. No problem. Is this clear?
Yes, sir.
Okay. So meanwhile, Krishna will be back. We will quickly recap. Okay.
Okay, sir.
What is the third law of motion?
Uh, to every action, there is an equal and opposite reaction
Okay. Why Apple is falling towards the Earth?
because of gravitational pull.
Who is exerting force on the Apple?
The Earth is exerting force on the apple.
Is Apple also exerting force on the Earth?
Yes, sir. It
Then
is.
why Earth is not moving?
Sir, because apple's mass is mass is less and force is also less as compared to that of the Earth.
So the force which Apple is exerting on Earth is very less.
Less.
Okay, because of this equation, so the mass of Earth is too large, and that is why the acceleration on it will be very less. That is why Apple is exerting force on the Earth, but the magnitude is very, very, very small. That is why the Earth is not moving.
Okay, sir.
Correct? So
Yes.
each one of us is exerting force on the Earth, but the Earth is not moving. Why? Because the mass of Earth is too large,
Compared.
and that's why the acceleration is very less, very small.
Okay, sir.
Clear?
Yes, sir.
Okay. If something is moving, it means a force has been exerted on it.
Yes, sir.
Yes. Okay.
S-
If
Sir, but in space, objects keep on moving without any force applied
no,
on them.
force is also applied on it. In space means you are talking about astronauts.
Huh, yeah.
So they also have a lot of equipments which is exerting force on them, and that is why they are in the space. If suppose they don't have those machines and those equipments, they cannot go like that in space, right? Correct?
Yes, but I've read it somewhere if we take an object and we give it a little push, it's
Hmm.
like for its entire life it'll keep on rotating or moving
In
in
the
a
space, that velocity is known as escape velocity. Okay, it is something like 11 kilometer per second. Okay, if you throw something with this speed, around 11 kilometer, I forgot, I need to check. Okay, if you throw something with this speed, it will go into a space and it will keep on moving there.
Okay. Okay, sir.
Is that clear?
Yes, sir, I got.
Okay, give me an example of circular motion.
Circular motion. Sir, when we take a stone, tight thread and we rotate it.
Correct. That's an
And
example of.
And
Circular motion.
athlete going in a circular path.
Hmm.
Earth revolving around the sun.
Correct. Okay, that's an example of circular motion. Okay. Now, why these planets are moving around the sun?
So because uh, sun also exerts pressure on.
No, not pressure, not pressure,
Force.
force.
Sorry,
Ah,
sorry.
sun is exerting force on these planets. So
Okay,
that
sir.
is why these planets are moving around the sun. Got it?
Yeah, yes, sir.
Okay. Now, if this boy will leave this thread, where this stone will go, in which motion?
Sir, it will go in like straight line.
A straight line motion, right?
Yeah, yes, sir.
Okay. And how many tangents can be drawn on a circle?
Infinite.
Infinite number of tangents, right?
Yeah,
Okay,
yes.
good. So, fine, this is clear. So, what type of force Earth exerts on Moon?
Centripetal force.
Centripetal force. It means whenever a force is towards the center, that is known as centripetal force. Clear?
Yes, sir.
Okay. Okay, we have discussed till here. Okay, let me complete this. In our solar system, all the planets go around the sun. By arguing the same way, we can say that there exists a force between the sun and the planets. From the facts, Newton concluded that not only does the Earth attract an apple and the moon, but all objects in the universe attract each other. This force of attraction between objects is called the gravitational force. So each one in this world which has a mass, they're attracting each and every other object. Okay? You
Yes,
are
sir.
applying a force on the wall. Wall is also applying a force on you. So each and every object which has a mass, they are applying force. Correct? And
Yes.
that force is known as gravitational force. So gravitational force is the force of attraction between objects. And because of that, the objects, they exert force on each other. So if Manaswini, you are applying force on the wall and the wall is applying force on you, then why you are not moving?
Sir, uh,
The
sir,
magnitude is very low, very small. So that is why you are not able to move. But when the earth is exerting force on you, that magnitude is too large. And that
yeah.
is where we are getting attracted towards the earth.
Okay, sir.
Clear?
Yes, sir.
Fine, then we will stop here. And but this chapter is very interesting. I will try to complete this chapter. And Shala madam is taking the test of which chapter?
No, sir. She will be starting exercise questions.
Okay, fine then. So I will take today is Tuesday, no? So tomorrow also I will try to take the class and I will teach you gravitation. So how you found it so far? Able to understand?
Very
Yes,
much,
sir.
sir.
Okay, good. So we'll
Sir,
continue the discussion tomorrow about gravitational force and many other things. Okay? But
sir, do one
bef
thing, sir.
1 minute, yaar, 1 minute, Krishna, you are
Okay, sir.
interrupting, yaar.
Okay,
So
sir.
before attending tomorrow's class, whatever I have covered so far, you have to revise it. First of all, for the first 10 minutes, I will take tests.
Yes, sir.
Okay? And then I
What
will resume the class.
about
Sorry?
what you taught us to?
Whatever I covered today, yes.
Okay.
Okay?
Yes, sir.
Okay, fine then. I'm getting one important call and then we will connect tomorrow.
Sir,
Okay?
tomorrow at what time, sir?
Tomorrow, same time, sir.
5:30.
Yeah.
Yes, sir.
Sir, I wanted 5, sir, because tuition. Another tuition.
I will let you know. I will let you know. Okay.
Sir, can you please send me that Excel sheet?
Yes, sir. I will send it to you.
Okay, sir. Thank you, sir. Bye, sir.
Thank
Okay.
you, sir.
Thank you. Thank you. Take care. Bye.
Bye, sir.
Bye.